Okay, welcome back to Differential Calculus. I am your tutor Ryan, and this is lesson 3 of basic derivatives. We are still doing polynomials, and last time we completed problems A, C, D, E, and F over the course of 2 videos. This video will be concentrating on different questions you're going to be asked to that involve graphing of some nature. So problem 1A, we have f of x, f prime of x, and it's asking us to graph both of these. So we're going to do that just now. This problem is a linear equation, and its derivative is just a constant, so there's not really too much we can do here, but this is just a good starter. Alright, so you can see here we already have plotted the function for x. At x equals 1 we have y equals 4, and at x equals 2 we have y equals 8. That's the result of plugging 1 or 2 into f of x. So I guess what we should do now, since this is what it's asking us, is to bring up its derivative, and I'm going to do just that. And as we know that its derivative is just 4, so it's going to be a horizontal line of 4. Of value 4 everywhere. So we'll plot that in black for you so it stands out. And there it is. So we have f of x plotted, which is a line, and we have f prime of x, which is plotted, which is also a line, but it's horizontal because it's a constant. So at every point along x, it will have the exact same value. You can be asked to, solve, where are these two functions equal to each other. We can see they cross over where 4x equals 4, and that's always at 1. So that's about it for this. We'll move on to the next one. Alright, so problem 2a. We have the original function, f of x equals 8x squared, and the derivative, which is equal to 16x, and they want us once again to graph f of x and f prime of x. Then there's the second part to the problem, where it asks us to find where f of x is equal to f prime of x, and then plot the point. And then finally, it asks us to plot the tangent line to f of x, where the tangent line has a slope value of 6. And before we get into that, I need to teach you what a tangent line is. So we'll do that now. Alright, so tangent lines, what are they? A tangent line to a curved function is a line which touches the curve at just a single point. At this point, the tangent line is in the same direction as the curve is, and has the exact same slope as that point on the curve. Some curves have several points where the tangent line has the same slope. Specifying a point helps you to determine which one you're looking for. If a function has more than one point where the tangent line has the same slope, you may be asked to list these points in the form x, y. Alrighty, back to the requests of problem 2a. We're going to move on. Okay, so now what we're going to do on this graph here is we're going to plot 8x squared. And because the function belongs to the form of x squared, it's going to be a parabola. So let's bring that up now. And here we can see the function 8x squared. So at the value of x equals 1, we have x is 1 squared, which is 1. And then we multiply that by 8. So it'll be here. Also, any negative value squared becomes a positive value and multiplied by 8. So it mirrors itself. This is an even function. Alright, so they want us to plot its derivative, which is 16x. And as we already know, 16x is a linear equation of form mx, where m is the slope. So we have this right here. Here it is again in a much nicer form. Okay, let's move. Alrighty, so part 2 of problem 2a asks us to set 8x squared equal to 16x, and then find out where they're equal and plot the point. So we've done that. X squared is the same thing as x times x. We can rewrite it like this. We notice that there's x's on both sides. We cancel out until there's no remaining x's. We're left with 8x equals 16. So now we want to get x all by itself, and in order to do that we need to get rid of the 8, so we divide through everything by 8, and we are left with x is equal to 2. Now if we're not sure of our answer, we can check this. We do this by plugging the value of 2 into f of x and f prime of x. So the 2 is taking the place of the x, gets subbed into the equation. We've got 8 times 2 squared, which is 8 times 4. That's 32. It's not too hard to see how that works. And now we got f prime of 2. That's equal to 16 times 2. The 2 takes the place of the x. That's also equal to 32. So as we can see, 32 does in fact equal 32. So let's move on and plot it. You'll see a familiar graph with the point 2, 32. Alright, so the last part of problem 2a asks us to plot the tangent line to f of x where the tangent line has a slope of 6. So how do we go about doing this? Well, we know now that the equation of the tangent line to f of x equals 8x squared is f prime of x equals 16x. The value of f prime of x is the slope of the line, the tangent line, at a specific point. So we must set f prime of x equal to 6 and then find the corresponding value of x. And we know that f prime of x is also 16x. So 16x must equal 6 for this to be valid. So, as before, so below, 16x divided by 16 is equal to 6 divided by 16. We're left with 3/8, which is 0.375. And then that value of x is plugged into f of x to find the corresponding y point on the graph, which ends up being 9/8. Thus, the point at which the function f of x has a slope of 6 is the point xy equals 3/8 and 9/8. Alright, so here we show the graph with the tangent line to the original function of 8x squared in green. And we're going to zoom out here, and that's just going to give you a little bit better of a view to show you what's going on. And of course that will touch the curve at 3/8 and 9/8. That concludes this video. We're going to be tackling problem 3a in the next video, which states that f of x is 12x squared plus 7x plus 36, and its derivative is 24x plus 7. The following 3 questions will be asked of you. Graph them, plot the tangent line, where the slope of the tangent line is 15, and then determine the equation of this tangent line. If you're feeling bold, you can go on ahead and do this for yourself and come back to part 4 and see if you're correct. Also, in part 4, we'll finish off that video with answering the original example problem that was posed in video 1, which reads, find your instantaneous speed at t equals 3 seconds. All the information that we need is above. So, yep, that's what you can look forward to. So come back for part 4. Don't forget to rate, comment, and subscribe. It's much appreciated.